Hello and welcome to my channel. In this tutorial, we will learn how to prepare a web application that requires a build step to run in a Docker container. So let's get started. First, we will need an application to work with. For that, we will use the Vue Cli to scaffold one for us. Let's start by installing the Vue Cli tools. Now that we have them installed, let's create a Hello World application. We will use the basic defaults as the application only serves the purpose of building a web application that uses a full-blown build system. As you can see, the application was created in the Hello World folder and we can run it in development mode by running the npm run serve command. The application will be available on port 8080. And there is the application. As you can see in the console, the app uses hot module replacement, or HMR for short, which is a good sign that we are in development mode. Obviously, there is nothing stopping you from running your application just like that in production, maybe besides degraded performance. But if that's not an issue, which it rarely is with Vue.js applications, you could call it a day. Or could you? The main problem with that way of serving your application is that each connected client would need not only to download the entire application, but will also need to keep an open WebSocket connection that listens for changes to the server to hot reload parts of the application. Now that is definitely not something you want because the HMR can cause unpredictable full-page reloads if the file being saved is not a Vue.js single file component. What you need in production is a pure, statically served set of files that the browser will be able to download and cache so that your application starts quickly. The Vue.js CLI already provides the means to build such a set of files using the npm run build command. The generated files land in the dist folder, which will become very important throughout the entire tutorial, so don't forget. This folder contains your application stripped down to bare minimum, and all it requires is any kind of HTTP server to host those files, so that the browser can fetch them. Luckily for us, there is a number of HTTP servers to choose from, like Apache or Nginx, just to name a few. There's even an HTTP module that can serve files over HTTP. It's a package called, surprise surprise, HTTP server. Let's go with that one first. You can install it just like any other global npm package. Once installed, a new command becomes available. It takes the name of the directory to serve files from as a parameter. Remember where our build artifacts went? Yes, to the dist folder. Now that we have the HTTP server running, let's check what's different in our application when it's run in the browser. As you can see, there are no development-like messages in the console and the files retrieved from the server are matching the ones that the build system said it produced. Neat, isn't it? We are getting close to having a production-ready version of our application. All that is left is to package it. In the recent years, Docker has become the de facto standard for cloud-based deployment, so let's go with Docker. At this point, I will assume you have already Docker installed and that you have at least some basic knowledge about Docker. However, if it is not the case, then you can learn about Docker from the many freely available resources on the internet. It really is quite a blast once you start exploring what Docker can do for you. I'll leave some links to good Docker tutorials in the description below. So, assuming you have the Docker installed, we will need a Docker file to tell Docker what to put where in the container. Luckily for us, we don't need to start by installing the operating system and Node.js on top of it. There are pre-made images that you can start building your containers from. We will use the Node container as our base because, well, the build system for our application as well as the HTTP server package are based on Node.js. The few lines that you see here are a direct copy from Vue.js documentation. You'll find a link to it in the description below. Now that we have our application built in the container, we need to serve it as well. For that, we will need to install the HTTP server package and expose port 8080. Last but not least, we need to tell Docker that whenever someone wants to run the container, the command will be http server with the folder where the build app files are. Let's build the container. We will need to give it a tag, which is a name that we will be referring to our build image later on. Now let's start the container to test if everything is working properly. We will make a temporary container. We will also attach standard input and output so that we can kill the app by pressing Ctrl+C. We will tell Docker to expose on port 8080 from the container. I know the syntax is quite confusing at first, but we will get used to it. Last but not least, we need the name of our image, which we have given while building the application. And sure enough, the application is running on port 8080 and is in proper production mode. Let's now examine how big the resulting application is. Oh my, 1.25 gigabytes! That's a bit much for a simple scaffolded application, don't you think? There are 3 reasons for the actual size of the final container. The first one is that while copying all the files from our disk to the container, we've also included the Node modules folder, which is big. Since we install the packages as a build step in the container, we really don't need to include those files from the hard drive. We also don't need the dist folder, as this is being built as part of the container as well. To get rid of those files, we can create a .dockerignore file and just name the folders and/or files that we want Docker to skip while copying the files. For now, we will include the Node modules, dist, and Docker file. Let's build the container again and see how big of a difference it made. Well, it's 100 megabytes smaller, not bad for 3 lines of additional text in one file, but we can definitely do better. The second reason the image is so huge is that we are basing our build system on the default version of the Node container. This one is built on top of Debian. I don't think we need a full Debian server Linux to simply serve a few files, right? There's another version or tag of the Node container that is built on top of Alpine Linux, a very small and lean distribution that would serve our needs much better. To do that, we will add the Alpine tag to Node image and rebuild it. Look at that! The image is only 246 megabytes in size. However, if we look at the comparison between the size of Alpine Linux itself, you will notice that now the actual size of our application is more than twice the size of it. The third reason the image is so huge is that the build artifacts alongside the source code are still in the container. We definitely don't want them and don't need them when running our application in production. They are simply dead weight. Docker has this fantastic tool called multi-stage builds. What it means is that you can build everything in one temporary container, and then you're able to just copy files you're interested in into the final container. Exactly what we need. To do that, we will name our first container build. After the application is built, we will create a second stage where we only copy files from the final dist folder and include the HTTP server package. Now look at that, the size of the image is just 7 megabytes more than the base image. Those 7 megabytes are mostly occupied by the HTTP module. Knowing that, let's take a look at some other options when it comes to serving files over HTTP. Among the obvious choices like Apache and Nginx, there is a number of less known but way smaller ones. For example, the Caddy web server. Let's see how much smaller we can go by not using HTTP server npm package, but instead using the Caddy web server. Caddy by default serves files from the /usr/share/caddy folder, so we will copy our build artifacts there. Let's build our container image and see the size of it. Wow, 39.8 megabytes in total, of which only about 600 kilobytes is the difference from the original Caddy image. Now you might ask yourself why the size of the difference between the underlying image is important. Well, Docker uses a file system that works like layers of a cake. Whatever changes in the new layer doesn't change the layers below. But most importantly, what is being actually stored is not the entire image, but just the difference. This means that when you'll be pushing your application image to the Docker repository, all that Docker will need to send over is just a difference, nothing more. And that can speed up your deployment tremendously. Okay, that's it for today's video. If you found it interesting, give it a thumbs up. Remember to subscribe to not miss any new tutorials and click that bell button to get notified when new content is available. Till next time, bye bye!